Hello, learners. We're going to be talking about a compound microscope today, and I'm going to read to you the article Through the Compound Eye. This is from the unit Structure and Function. Paragraph 1. For thousands of years, human beings have used tools. For a biologist, one of the most important tools is the microscope. Since its innovation in the late 1500s, the microscope has transformed into a relatively inexpensive yet effective way for scientists such as yourself to view a world invisible to the naked eye. Advances in microscope technology have led to the discovery of cells, cellular structures within cells, microorganisms such as bacteria, viruses, and more. Microscopes allow doctors to regularly analyze tissue samples from their patients to determine various illnesses, parasites, or even medical issues. Scanning electron microscopes are extremely powerful and can magnify an object up to several million times its normal size. These microscopes help scientists view tiny viruses and develop vaccines and cures for infectious diseases. Other electron microscopes can be used to create enlarged images of small structures, such as silicon chips. Silicon chips are used in electronic devices to improve their performance. The enlarged images allow engineers to fit more circuits on the silicon chip, which, in turn, creates a more efficient electronic device, such as a new cell phone. The many uses of microscope technology aid our understanding of the microscopic world and allow scientists to make further advances in the scientific community. You will be using a compound light microscope during this unit. In this type of microscope, light is provided either by a mirror or a small built-in light bulb. The word compound refers to two lenses, one in the eyepiece and one in the objective lenses, that together magnify the image. You can calculate the total magnification by multiplying the magnification of the lenses of the eyepiece by that of the lenses of the objective. The image on the facing page displays parts of the compound microscope and explains the function of each part. To use the microscope, you must follow 8 steps in sequence. These are listed below. Review the steps and keep this list for reference when you look at a microscope slide through this lesson. Step 1. Turn on the light near the base so you can see the field of view while looking through the eyepiece. Step 2. Open the diaphragm found under the stage. The diaphragm regulates the amount of light and is perhaps the most misused or underused feature of a microscope, yet is one of the most important tools for optimal viewing of an object. When viewing a specimen, too much or too little light will decrease the contrast or image quality. Step 3. Turn the revolving nosepiece and make sure the low-power objective, or the shortest lens, usually 4x, is clicked into place, perpendicular to the stage as shown in the image above. Step 4. Place the center of the microscope slide over the hole in the stage and secure it with the stage clips. Carefully move the stage clips over each end of the slide. Center the specimen in your field of view if needed. Step 5. While looking from the slides, use the large coarse adjustment knob to fully raise the stage. Do not allow the objective lens to touch the slide. Step 6. While looking through the eyepiece, use the coarse adjustment knob to focus an image as you slowly change the distance of the stage and objective lens as seen in the image to the right. Step 7. Stop moving the coarse adjustment knob when the object comes into focus. If necessary, use the fine adjustment knob to focus the object more clearly. Step 8. Close the diaphragm slightly so that the image is still visible. This should decrease the contrast of the image. As you can see, there is a diagram of a compound light microscope. There are 12 different parts. Let's talk about each. Part 1, the arm. The arm supports the stage and upper part of the microscope, and it contains the focused adjustment knobs. Part 2, the base supports the microscope. Part 3, the coarse adjustment knob. It raises and lowers the stage or objective lenses. 4, diaphragm. This is a wheel or lever that adjusts the amount of light that passes through the hole in the stage into the specimen. Part 5, eyepiece. The part of the microscope through which you look contains usually a 10x lens. 6. Fine adjustment knob that raises and lowers the stage a tiny distance for exact focusing. 7. Light. It sends a light through the hole in the stage to illuminate the species on the slide. 8. Nose piece. It holds the objective lenses, rotates to enable clarifying changing magnification. 9. Objective lenses. These are used in combination with the eyepiece and provide a range of magnification, usually from 4x to 10x, 4 to 40x. On-off switch that turns the light source on or off. 11 is stage that supports the slide, and finally 12 stage clips, usually one on each side of the hole on the stage, and it helps hold the slides in place. So once again, students, this was the article Through the Compound Eye from the unit Structure and Function. If you have any questions, of course, you can talk to your teacher.